Following is example C3 from the midterm review. This is a max-min question. The velocity of the air when you cough is given by this equation, where A is a constant radius when not coughing, K is a constant, and R is the radius while coughing. What is the value of R for the maximum velocity? So since we know K and A are constants, R is the variable that's changing. This is an equation with respect to R, which is one variable. So with all max-min questions, we start with a primary equation. What is it we're trying to maximize? So in this case, the velocity. So the equation for velocity is kr squared a minus r. A is constant, k is a constant, so this is with respect to r. Only one variable, one thing that's changing, so we can start by doing the derivative. Remember, for max-min questions, if we have more than one variable, we need a secondary equation to replace the extra variables. But since we only have r that's changing, we can take the derivative. Two ways we can do it. We can use the product rule straight from this step, or we could actually simplify this step first. It's kr squared a minus k r cubed, and take the derivative from there, which is probably simpler. So that gives us 2k ra minus 3k r squared as the derivative. Set the derivative equal to 0. That lets us find the possible values for r for a maximum. So 0 equals 2k ra minus 3k r squared. If we now factor out r and solve the resulting equations, we get 0 equals, well, we can factor out k as well as common, so kr outside of 2a minus 3r. Since the product of these equals 0, then either r equals 0 or 2a minus 3r equals 0, which means that r equals 2a over 3. So there are the values for r that give a maximum velocity.